Hi guys, Mr. Pratama is here and today we are going to talk about radiations. In the chemical reaction, only the atoms from substances are rearranging when chemical bonds breaks into its forms. The identity of each individual atom remain unchanged. But in the nuclear reaction, changes occur to the fundamental particles in the nucleus of an individual atoms, which means it will change from one element to another element. These reactions are some kind of nuclear decay where something in the nucleus disintegrates, giving off some form of radiations in the process. There are three kinds of radiations from a radioactive elements. First, an alpha particles is essentially a helium nucleus with two protons and also two neutrons. Emitting an alpha particles will result in transmutations or change in the form of elements, as we can see here. Second is a beta particle, which is actually an electron. Along with it, there is a positron, which is the antimatters of an electron, which has the same mass but positive charge. A third kind of radiation is gamma particle, which is the photon of light. Let's quickly learn the way that we can notate these particles so that we can write the nuclear reaction. A proton and neutron will be signified this way with the P and N, each with mass 1, but only the proton has atomic number 1. An alpha particles can be represented as a helium or with the alpha symbol. An electron can be either an E or beta symbol, and the atomic number will be -1 and the mass number is 0. A positron will be the same, but with a positive 1 here. And a photon will be gamma with both numbers are 0, as it has 0 mass and also no atomic number. So, if we want to describe an emission of an alpha particles, we will write it is this way. Show the first particles and then arrow, which signifies their reaction, and then show the alpha particles to figure out the resulting nucleus after emissions. We just simply do the arithmetics because the atomic numbers and mass numbers have to add up to the same number on both sides. As I have mentioned in the previous video, if the nucleus is too large, it will emit an alpha particle, or it can undergo spontaneous fission where it breaks into multiple lighter nuclei and usually a few neutrons. In beta emission, the reason an electron is emitted is because a neutron is spontaneously transformed into a proton. A nucleus would do this if the ratio between the neutron and proton is too big. Positron emission is just the opposite of the previous one. When protons becomes neutron, this will emit a positron. This will happen if the ratio between neutron and proton was too small. With both of these type of decay, there is also a tiny particle that we call the neutrino. In beta emissions, it's anti-neutrino, and with positrons emissions, it is the neutrino. And lastly, if a nucleus is in excited state, it can emit a high energy gamma photon. In this process, there is no transmutation because we don't change around any protons or neutrons. So, by this, we can conclude that if there are too many protons, there will be positron emission. If there are too many neutrons, there will be beta emissions. Next, if the nucleus is too big, there will be an alpha emissions. If the nucleus is an excited state, there will be gamma emissions. Okay guys, that's it for today. But wait, don't forget to do today's assignment and submit it via Google Classroom. See you and bye-bye.